So, we're looking to talk about web APIs today.
Yeah, absolutely. So, actually, more than just web APIs, you wanted to talk a little bit about REST and what it is and what a web API is. I mean, I think we're kind of targeting this towards folks who are kind of new to the field and helping them to understand what a web API is.
Wait a minute. Web API and REST aren't the same thing?
I don't think they are they?
No. In fact, a REST-based API is actually an architecture. A lot of people seem to get those, two things confused. To actually be REST, you have to, adhere to some constraints.
Well, before we get there, we'll get there, but let's back up and define what a web API is. Let's define what an API is in general.
Sure. So you're looking, with just the API, it's an application programming interface. You're programming against a interface that allows you to interact with the application. A web API actually does this over the HTTP protocol.
Okay, so what does that mean to me as a new developer?
Well, as a new developer, that means that you're able to use the internet to be able to talk between different clients. So I can have a web API, and you can have a mobile application, and Jim could have a desktop application, and Larry could have a desktop web application. All of these will still come to my API and be able to interact and get data. However, I don't care about what your application's really doing.
So this is a mechanism to transfer data back and forth. Can I do anything else other than transfer data?
Well, you're transferring data. You can be executing code on my server and causing states to change.
Okay, very interesting. So APIs give developers a way to interact with remote systems.
Yep.
In this case, and web APIs particularly give developers a way to do that over the internet.
Yeah, over the internet, over the HTTP protocol.
Okay, yep. Excellent. Well, is it always over HTTP?
No, but that is the more popular one.
More popular, and that actually is REST, which you mentioned earlier.
That's correct.
So REST is it stands for representational state transfer. It's a big word.
Yep.
It's a confusing thing for new people to understand, and that's okay. We can kind of break that down and talk about what it is and why it's important.
Sure. So representational state transfer, a lot of people say they're a REST-based solution. However, you do have constraints to adhere to them, and one of them is that it has to be stateless. Part of the representational state transfer is to be stateless.
Okay, now you've mentioned state a couple of times. What do you mean by that?
So, as web developers, we're used to handling something called session. To keep when I talk to a server or talk to an endpoint, I'm talking to them as if they know who I am.
Okay.
Right? Between requests, I go, hey David, I want this information. I'm going to change something, and about everything I've done leading up to that point.
Okay.
In a REST-based system, you need to be stateless to be able to say, okay, well, client, I don't know who you are. Everything that I have right now, I'm treating as if you've come to me for the first time.
Okay, now you mentioned as a web developer, we're used to using session, but actually session and some of those things are just a way to actually just fake state anyway, because the web is a stateless thing.
It is. Yep.
So if we take it back to the thought of old days when we had Windows-based or executable applications that ran on our local machines, state was a way of keeping track of the things in memory that are always there, are always persistent as long as our application's running and those things are in scope. But when we communicate over a protocol like HTTP or any web-based protocol where our systems are separated not only by what am I trying to say? Not only by space, but by
time.
connectivity. Because and that's what I'm getting to. I'm sorry. By connectivity, because they are not persistently connected. So, in order for a web server, for example, to maintain any semblance of scalability, it must not keep everything in memory for all the clients it's been talking to.
Yeah. And what would happen if that server ever did go down,
right?
And get recycled? You want the clients to be able to still run, still hit your service on the next time it comes back up.
Absolutely. So stateless is a way of saying that all those variables, those things that we store in memory about our application, simply just go away between every request.
Correct. So speaking of requests, one part of being REST is doing it on a unified interface. So we're actually coding against the HTTP methods and using the HTTP protocol as our interface.
So the methods. So we talk about HTTP verbs. Mm-hmm. What are those verbs?
So you're looking at get, post, put, delete, and patch as the current standards for those verbs.
Okay. And what does that mean to me as a developer? How do I use those things to communicate with a remote client or a remote server?
Sure. The current standards, as they're currently written now, is if you're looking to get a resource, and we define a resource by the URL. So if I wanted to say /expense groups /1, I'm looking for the expense group 1, data to come back. And I do that through a get. If I'm looking to replace that expense group, I'm going to be doing a put. If I'm looking to create a new expense group, I would actually be doing a post, but on a different URL. I would actually be doing that on just /expense groups.
Okay.
And if you're looking to remove the expense groups, you go back to the resource URL, which is expense group /1, and issue a delete verb to be able to remove it. And just recently, 2010, they released the patch verb, and that allows you to update a resource or apply operations to a resource based off that URL.
Okay. So how does the system know if I tell it that I want to delete? How does it know how to do that?
Well, that is actually so one of the constraints is that it is a layered system. So you are programming against a unified interface, but you're making the request, the HTTP request, using the verb delete.
So REST is all about making requests of the server.
Correct. And since the other constraint is that your server is layered, it doesn't know anything about the UI, and you as a client should not know anything about the backend portion of how it actually deletes. It just knows that against this interface, I know that I'm going to cause a delete to happen on this resource.
So that goes to that big word we use from time to time, encapsulation.
Correct.
The API is actually encapsulating the functionality of what happens when I ask for a delete to happen away from me. I just know that I have some specific resource I want to delete. I make the request of the server and issuing the right verb and the right value, key value, whatever that is for however I want to represent that object. This is the resource I want to delete, and it knows how to do that. I don't care about that.
Correct.
Okay.
Yep. The other things that, and this is actually a standard that is optional in REST, that not very many people know or use, is the code on demand,
Okay.
where you can actually have it execute pieces of code or functionality on your server.
And how does that work?
So this is so that you can be able to, extend your APIs, allow your clients to be able to extend with you by increasing your API's functionality. But it basically allows you to point to an endpoint and tell the user saying, hey, if you want to add me, here's this other endpoint. Here's the URL that you need to use to go here.
So can you give me an example when that might be valuable? Some process or some real world example?
Sure. Are you familiar with Trello?
I am.
Okay. So Trello allows you to be able to move cards between swim lanes. Well, columns, really.
Okay.
Right. Their API basically says, I have a card ID, which is a resource URL, and I would like to, know what I can do with that. Based off that, it will actually give me the list of things that you can do. You can move a card. Mm-hmm. I can archive a card. I can delete a card. Right. It actually gives me the endpoints for those and the action that I need to take, and that actually comes back when I retrieve the card through a GET.
Okay. So that's the example of running some code on the server then.
Yeah.
Okay.
Well, that allows my service to be able to give you, options, and then you can turn around and use those options and run that on my server.
Excellent. So, as a developer, I'm just learning about these web API things and using REST as an option for that. When would I want to do this? When do I need to use a REST API, and what benefit is it to me?
Sure. So anytime that you're doing, remote data, a great example to do REST-based APIs is, when you're dealing with, a mobile application, right? I have a large set of data and I need to be able to have access to it, and I have multiple client types connecting to me. Rather than duplicating that code of, getting this data and manipulating the state of that data, I don't want to have to duplicate that code 3 different times for 3 different operating systems. This is where an API, especially a REST-based API, comes in handy.
Excellent.
One of the states that we actually didn't mention was caching. To be a RESTful API, you need to cache, especially on the mobile side. When you don't want to take up the user's data plan, caching becomes a big thing.
So what is caching exactly for those who might not be aware?
Sure. Caching allows you to be able to say, I have the /expense groups /1, and when I get this resource, I go back to being a resource is what you're looking at. When I get this resource of the expense groups, that request should tell me whether or not it's cacheable. And by default, GET requests should be cacheable. It gives me something called an E tag. That E tag allows me to say, hey, has this resource changed? I'm going to cache it on my system, so the next time I load, I make a request saying, this E tag, is it still up to date? The server says, yes, I've cached that E tag and it hasn't changed. So I'm going to give you back a 204, nothing has changed.
Okay, so I get some kind of a status saying the data that I already have on my side is still valid. Don't refresh it. That's kind of the idea?
Correct.
Just keep this current data because nothing's different.
Correct.
Okay.
So if I go to /expense groups and nothing on that resource for, where it comes back and gives me information about an array has changed, then I can go ahead and display to my user what I already have on my device.
Excellent. So I understand you're going to be doing a series of blog posts on REST APIs. I think it's a little more in depth. It involves OData as well.
Mm-hmm. I'll be doing a how to extend your REST-based API using OData version 4.
Excellent. Well, how about we do another episode here soon where you kind of talk about OData and introduce that to us?
Sure. I can be able to do a small complimentary guide on OData, using the stuff that we will be doing in my meetups.
Excellent. Well, thank you, Randall. Thank you for joining us today again, and we'll be looking forward to talking more on some of these subjects in the future.
Thank you.